October 12, 1944. Rechlin Testing Center, Mecklenburg, Germany. The twin-boom silhouette of the Lockheed P-38 Lightning sat incongruously among the sleek single-engine fighters that lined the test facility's hard stand. Its distinctive shape, painted in Luftwaffe yellow identification markings with the code T9 plus MK hastily applied to the fuselage, drew curious stares from ground personnel who had never seen an intact example of America's premier twin-engine fighter up close. Hauptmann Werner Baumbach, a veteran test pilot with over 3,000 hours in German fighters and captured Allied aircraft, circled the Lightning slowly, his practiced eye taking in details that would have been invisible to untrained observers. The aircraft had arrived at Rechlin 3 weeks earlier, recovered from a forced landing near Aachen after its pilot, Second Lieutenant Joseph Schaefer of the 55th Fighter Squadron, had nursed his battle-damaged Lightning as far west as possible, before fuel exhaustion forced him down in territory that remained, for a few more weeks, under German control. The recovery had been remarkably swift. German salvage teams, operating with the efficiency born of desperate necessity, had reached the crash site within hours, secured the aircraft against advancing Allied ground forces, and transported it by rail to Rechlin before American artillery could render the wreck useless. The Lightning's damage was substantial but repairable. One, Allison V. 1710 engine, had taken cannon fire that destroyed several cylinders, but the other engine remained largely intact. The left boom showed significant structural damage from the forced landing, but German technicians, working with remarkable ingenuity given their limited resources and complete lack of manufacturer documentation, had cannibalized parts from 2 other P-38 wrecks recovered earlier in the year. What emerged from Rechlin's workshops after 6 weeks of intensive labor was not exactly the aircraft that had left Lockheed's Burbank factory in early 1944, but it was sufficiently airworthy for the purpose at hand. The Luftwaffe needed to understand this aircraft, not merely through fragmentary combat reports and intelligence assessments of uncertain reliability, but through direct, systematic evaluation by experienced test pilots who could quantify its capabilities and identify whatever exploitable weaknesses might exist. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Baumbach had flown captured aircraft before. The Wander Zirkus Rosarius, officially designated as the second staff of the Erprobungsstelle der Luftwaffe, had exposed him to Spitfires, Thunderbolts, and Mustangs, each revealing uncomfortable truths about Allied engineering capabilities that contradicted years of official propaganda. But the P-38 represented something different, something that challenged fundamental assumptions about fighter design philosophy itself. The Germans had experimented with twin-engine heavy fighters, the Messerschmitt Bf 110 most prominently, but those aircraft had proven vulnerable in combat against more maneuverable single-engine opponents. The conventional wisdom within the Luftwaffe held that twin engines meant weight, complexity, and reduced agility. Acceptable sacrifices for long-range bombers or night fighters, but fatal compromises for a daylight air superiority fighter. Yet the Americans had fielded the P-38 inches, both Europe and the Pacific, and combat reports suggested the aircraft possessed performance characteristics that seemed incompatible with its configuration. Intelligence indicated top speeds approaching 400 miles per hour, climb rates that rivaled single-engine types, and operational range that exceeded any German fighter by factors of 2 or 3. These claims strained credibility among German engineers who understood intimately the weight penalties and aerodynamic drag that twin engines imposed. The story of how this particular Lightning came to reveal uncomfortable truths to German test pilots begins not with Schaeffer's forced landing near Aachen, but with the escalating crisis in German fighter operations during the autumn of 1944. By October, the Luftwaffe faced systematic destruction across all fronts. The invasion of Normandy had succeeded despite fierce aerial opposition. Allied fighters now operated from bases in France, dramatically reducing the warning time available to German air defenses. American bomber formations penetrated German airspace daily, protected by escorts whose range, numbers, and performance overwhelmed diminishing Luftwaffe resistance. The strategic situation was deteriorating so rapidly that tactical intelligence about enemy aircraft capabilities, once gathered leisurely through careful analysis, now demanded immediate answers to urgent operational questions. How fast was the P-38 at various altitudes? How did its climb rate compare to the Bf-109G and FW-190A? Could it sustain turning combat with German fighters, or did its twin engines impose maneuverability penalties that could be exploited? Most critically, did the twin-engine configuration harbor inherent vulnerabilities that German pilots could target to even the increasingly lopsided combat odds? Oberst Theodor Rowehl, who commanded the Luftwaffe's captured aircraft evaluation program, understood that answering these questions required more than static examination and ground testing. The Wanda Zirkus Rosarius had proven the value of hands-on experience. German fighter pilots needed to fly against the P-38 to experience its handling characteristics directly and to discover through mock combat exactly where German fighters retained advantages and where they faced decisive disadvantages. The repair work on Schaefer's Lightning had consumed resources that were increasingly precious by late 1944. Aviation fuel for test flights was scarce, with operational units receiving priority. Skilled technicians were in short supply, pulled away for emergency repairs on operational aircraft or conscripted for infantry service as Germany's manpower crisis intensified. Spare parts were essentially non-existent, forcing complete reliance on cannibalization from wrecks. Yet Rechlin's technicians persevered, motivated by professional pride and recognition that understanding the P-38 might help German pilots survive encounters with an aircraft that seemed to defy the conventional wisdom about twin-engine fighter limitations. The two Allison V-1000, 700 and T-89, 91 engines presented immediate challenges. These were counter-rotating power plants, the left engine turning counterclockwise when viewed from the cockpit, the right engine clockwise, designed to eliminate the torque and P-factor asymmetries that affected single-engine aircraft. This arrangement was sophistication German engineers recognized and respected, but it complicated repairs because the engines were not interchangeable. Parts from a left-hand engine could not be fitted to a right-hand engine without extensive modification. German technicians studied the engines with intense professional interest. Each Allison produced approximately 1,425 horsepower at war, emergency power, utilizing a single-stage, single-speed supercharger with aftercooler. The supercharging was less sophisticated than the two-stage systems in the Packard Merlin engines that powered late-model Mustangs, but the installation was remarkably clean and accessible. German mechanics, accustomed to the cramped engine compartments of Bf-109 seconds where routine maintenance required extraordinary contortions, appreciated the P-38's spacious engine nacelles, where technicians could actually reach critical components without special tools or impossible angles. The turbo supercharger installation particularly impressed German engineers. Each engine featured a General Electric Type B, 2-turbo supercharger mounted in the tail boom behind the engine, using exhaust gases to drive a turbine that compressed intake air before feeding it to the engine's mechanical supercharger. This sophisticated system maintained sea-level manifold pressure to altitudes exceeding 25,000 feet, giving the P-38 excellent high-altitude performance without the weight and complexity of multi-stage mechanical supercharging. German attempts to develop reliable turbo superchargers for fighter engines had encountered persistent technical problems. The high temperatures and extreme rotational speeds proved difficult to manage with available materials and manufacturing tolerances. Yet here was an American fighter with turbo superchargers that, according to captured technical documents and pilot reports, operated reliably under combat conditions. The installation represented American engineering competence that contradicted comfortable assumptions about crude mass production, prioritizing quantity over sophistication. The cockpit layout also challenged German preconceptions. The P-38's office was spacious compared to the cramped confines of German fighters, with controls logically arranged and instruments clearly grouped. The control wheel, rather than a stick, felt unfamiliar to pilots trained on conventional fighters, but the ergonomics were clearly thoughtful. Visibility was exceptional, the clear bubble canopy and the Lightning's unique configuration providing sight lines that exceeded anything in German service. A pilot sitting in that greenhouse could see in all directions with minimal blind spots, a critical advantage in combat where the pilot who saw his opponent first usually survived. German test pilots noted these details with professional interest tinged with growing unease. The P-38 was not crude. It was not a simple mass-produced machine that sacrificed quality for quantity. It represented sophisticated engineering that successfully integrated complex systems into a coherent, functional weapon. The realization was uncomfortable because it suggested that American technical capabilities equaled or exceeded German achievements in areas where German propaganda had insisted on inherent Teutonic superiority. The first test flight was scheduled for October 12, weather permitting. Baumbach conducted his pre-flight inspection with methodical thoroughness, checking control surface movement, examining tires for proper inflation, and verifying that fuel tanks had been filled properly. The Lightning carried 410 gallons internally, distributed between main tanks in the center section and leading-edge tanks in the wings. With external drop tanks, total capacity could exceed 1,000 gallons, giving the aircraft range that seemed almost incredible to German pilots whose fighters barely exceeded 90 minutes of endurance. Ground crew helped Baumbach into the cockpit, a process complicated by his bulk and the various survival equipment required for test flights. Once settled, he began the start sequence, following translated procedures that Rechlin's intelligence section had compiled from captured technical manuals and pilot notes. The process was complex, reflecting the P-38's sophistication. Prime the engines, engage starters, monitor temperatures and pressures, check turbo supercharger operation, test generators and hydraulics. The left Allison caught first, its distinctive rumble different from the higher-pitched whine of German inline engines. The right engine followed seconds later. Baumbach let them warm up, watching cylinder head temperatures climb toward operating range while oil pressure stabilized. The engines sounded smooth, no misfires or rough running that would indicate problems. German maintenance personnel, despite their limited familiarity with Allison engines, had done remarkable work. Taxiing revealed the first handling, characteristic that would prove significant. The P-38's tricycle landing gear, with its nose wheel providing steering, made ground handling remarkably easy compared to German fighters with conventional tail wheel configurations. The Bf-109 was notoriously difficult to taxi, its narrow track and rearward center of gravity demanding constant attention to prevent ground loops. The Lightning tracked straight with minimal pilot input, the nose wheel providing positive directional control that reduced workload and prevented the ground accidents that plagued German fighter units. Reaching the runway threshold, Baumbach ran through final checks, then advanced both throttles smoothly. The Lightning accelerated rapidly, both engines delivering full power with the distinctive roar of 1,400 horsepower multiplied by 2. The acceleration was impressive, noticeably stronger than single-engine types, despite the P-38's greater weight. The tricycle gear kept the aircraft tracking straight down the centerline, without tendency toward torque-induced swerve. At approximately 90 miles per hour indicated, Baumbach eased back on the control wheel, and the Lightning lifted cleanly into the autumn air above Mecklenburg. The moment the wheels left the ground, Baumbach understood that American engineers had achieved something remarkable. The P-38 flew like a much smaller, lighter aircraft. Control response was crisp and immediate. Aileron forces were light but not overly sensitive. Elevator control was well harmonized, requiring reasonable force without being heavy. Rudder inputs produced predictable yaw without adverse coupling. The aircraft felt stable and solid, inspiring confidence rather than demanding constant attention. He raised the landing gear and felt the aircraft accelerate as drag reduced. Climb performance was excellent, significantly better than expected for a twin-engine fighter. The rate of climb indicator showed over 3,000 feet per minute at sea level, rivaling single-engine types and exceeding them at higher altitudes, where the turbo superchargers maintained power that naturally aspirated engines lost in the thinning air. Leveling at 10,000 feet, Baumbach began systematic evaluation, following test protocols developed through years of captured aircraft assessment. First, basic handling qualities across the speed range. He reduced power to idle and let the Lightning slow, monitoring how control forces changed and whether any dangerous characteristics appeared at low speeds. The P-38 slowed gracefully, control harmony maintained throughout, with adequate stall warning through buffet before the nose dropped gently in a straight-ahead stall. No wing drop, no tendency toward spin entry, just a straightforward stall characteristic that would be easy to recover from in combat conditions where a pilot distracted by enemy fighters might inadvertently slow too much. He advanced power and accelerated, pushing the Lightning through moderate speeds toward maximum velocity. The aircraft accelerated smoothly, engines delivering consistent power through the speed range. At 350 miles per hour indicated, control forces had increased as expected with dynamic pressure, but not excessively. The P-38 remained responsive, not requiring excessive strength to maneuver. At 400 miles per hour, still climbing to optimize conditions for maximum speed, the Lightning continued accelerating without encountering the compressibility effects that plagued many fighters at high speeds. This was revelation. German fighters encountered serious problems at high speeds. The Bf-109 suffered severe elevator control stiffening that required enormous physical force to pull out of high-speed dives. The WWII experienced aileron snatch and reduced roll authority approaching its maximum speed. Both types were effectively limited by these handling degradations, their pilots unable to safely exploit their theoretical maximum. Velocities in combat. The P-38 showed no such limitations in the speed range Baumbach explored during this initial evaluation. Controls remained effective and reasonably light, even at speeds exceeding anything he could achieve in a Bf-109 without entering a dive. The aircraft felt solid and controllable, free from the buffeting and control blanking that made high-speed flight so dangerous in German types. He initiated a series of turns at various speeds and bank angles, evaluating how the P-38 maneuvered. Sustained turn performance revealed the expected limitation. The Lightning could not match the turn radius of lighter single-engine fighters in level, moderate-speed turning combat. The Bf-109, particularly with its automatically deploying leading-edge slats, could turn inside the P-38 inches slow-speed fights. This was the weakness German pilots needed to exploit. But Baumbach, with thousands of hours of combat and test experience, immediately recognized the limitation's irrelevance in practical combat. The P-38's superior speed and climb rate meant its pilot could refuse turning engagements entirely. If a German pilot attempted to force a slow-speed turning fight, the Lightning pilot could simply accelerate away, using superior straight-line speed to open distance faster than the German fighter could close it. If the German pilot attempted to intercept from below, the P-38 could outclimb him, reaching superior altitude before engagement. If the German pilot attempted diving attacks from above, the P-38 could follow through the dive, its excellent high-speed handling allowing it to stay with or even catch the German fighter. The tactical implications crystallized with uncomfortable clarity. German pilots could beat the P-38 inches sustained turning fights, but only if the American pilot made the fundamental tactical error of accepting such engagements. A competent P-38 pilot flying energy tactics would be nearly impossible for German fighters to catch, much less shoot, down, under most combat conditions. Roll rate testing proved equally revealing. Baumbach snapped the Lightning through rapid aileron reversals, measuring how quickly the aircraft changed bank angle. Roll rate exceeded the Bf-109 significantly and approached the exceptional roll performance of the FOR-190. Combined with the P-38's superior speed, this meant Lightning pilots could change direction rapidly, either to pursue fleeting opportunities or evade attacks, then accelerate away before German fighters could counter. The dive test came next. Baumbach rolled inverted and pulled through into a steep dive, letting the Lightning accelerate toward terminal velocity. Speed built rapidly. 400 indicated, 420, 440. The airframe remained stable, no flutter or buffeting. Controls stayed effective, requiring increased force as dynamic pressure built but remaining responsive. At 460 miles per hour indicated, approaching the Lightning's published redline speed, Baumbach rolled wings level and pulled smoothly back on the control wheel. The recovery was uneventful, strong but not excessive, G-forces loading the airframe and pilot as the dive transitioned to level flight. No control lockup, no dangerous pitch-up or other departure from controlled flight. The P-38 simply did what the pilot commanded, exhibiting none of the frightening high-speed characteristics that made diving attacks so risky in German fighters. This capability had profound tactical implications. German fighter doctrine emphasized diving attacks against bomber formations and their escorts, using altitude advantage to build speed before engagement. The tactic worked because most fighters of the early war period could not effectively follow through steep, high-speed dives, allowing German pilots to attack and escape before the enemy could respond. But the P-38 could follow. A Lightning pilot could pursue German fighters through their diving escape maneuvers, maintaining control and firing accuracy throughout, then pull out smoothly and climb back to altitude to continue combat. The German tactical advantage was neutralized. Climbing to 25,000 feet, Baumbach evaluated high-altitude performance, where the turbo superchargers should demonstrate their value. The climb to altitude was steady and strong, engines maintaining power as the altimeter wound through 15,000, 20,000, 25,000 feet. At 25,000 feet, where German fighters with single-stage superchargers were gasping and struggling, the Lightning's engines continued delivering robust power. Baumbach advanced throttles to military power and let the Lightning accelerate. Even at this altitude, the acceleration was impressive, significantly better than any German fighter could manage in the thin air above 20,000 feet. Top speed at altitude would require extensive testing under precisely controlled conditions, but the preliminary impression was clear. The P-38 retained performance at high altitudes that German fighters simply could not match. This was perhaps the most troubling discovery. American bomber formations operated at 25 to 30,000 feet, specifically to degrade the performance of defending fighters. At those altitudes, German fighters suffered severe power loss, reduced climb rates, and degraded handling as engines struggled with the thin atmosphere. The P-38 escorts suffered no such penalty. They could fight at high altitude as effectively as at sea level, maintaining speed advantage and superior maneuverability, while German interceptors labored with progressively worsening performance as altitude increased. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. After 90 minutes of systematic evaluation, Baumbach returned to Rechlin and landed, the tricycle gear again, proving its worth with a straightforward landing that required minimal skill compared to the tricky three-point or wheel landings demanded by tail-wheel fighters. Taxiing back to the hardstand, he noted the curious crowd of pilots and technicians waiting to hear his assessment. His preliminary report to Oberst Rowehl was professional and factual, stripped of emotion but devastating in its implications. The P-38 Lightning represented sophisticated engineering that successfully balanced the competing demands of range, speed, altitude performance, and handling quality. The twin-engine configuration, rather than imposing crippling penalties as German assumptions suggested, provided advantages that outweighed limitations. The redundancy of two engines offered safety over water and hostile territory. The counter-rotating propellers eliminated torque effects. The twin-boom layout allowed a concentrated armament installation in the nose that simplified aiming and delivered devastating firepower. Most troubling, the aircraft demonstrated that American engineering could successfully solve complex technical problems that had defeated German attempts. Reliable turbo superchargers, clean high-speed aerodynamics, effective control harmony throughout the flight envelope, these were not simple achievements. They represented sophisticated analysis, careful design, and precise manufacturing. The comfortable assumption that American industry produced adequate quantity at the expense of quality was demonstrably wrong. Over the following week, additional test pilots flew the captured Lightning, each reaching similar conclusions through direct experience. Hans-Joachim Jabs, a veteran night fighter pilot with over 30 victories, flew the P-38 and immediately grasped why it proved so effective in both the Pacific and European theaters. The combination of long range, high speed, excellent visibility, and heavy firepower created a versatile weapon that could perform multiple missions effectively. Wolfgang Später, another experienced test pilot who had flown numerous captured types, noted in his report that the P-38's handling qualities were superior to German twin-engine fighters in almost every respect. The Bf 110, which had been withdrawn from day fighter operations after suffering unsustainable losses during the Battle of Britain, felt cumbersome and sluggish compared to the Lightning. The Me 410, its intended replacement, was faster, but still lacked the crisp handling and combat maneuverability the P-38 demonstrated. The systematic evaluation proceeded through October and into November of 1944, generating comprehensive technical reports that documented the Lightning's capabilities in detail. Performance was measured at various altitudes, airspeeds, and power settings. Handling qualities were evaluated across the entire flight envelope, from stall to maximum speed. Simulated combat engagements against Bf 109Gs and Fif 190, as revealed the limited circumstances under which German fighters retained exploitable advantages. The armament installation received careful examination. The P-38's nose housed one Hispano 20mm cannon with 150 rounds and 4 Browning 50 caliber machine guns with 500 rounds per gun. This concentration of firepower along the aircraft's centerline eliminated the convergence problems that affected wing-mounted guns in most fighters. The P-38 pilot simply pointed the nose at the target and fired, with all weapons impacting the same point regardless of range. The resulting accuracy was significantly better than dispersed wing armament, and the destructive power of one cannon plus 4 heavy machine guns was devastating against any target. German engineers noted that the ammunition capacity, while not exceptional by German standards, was adequate for typical combat engagements. More importantly, the weapons were reliable. The Browning 50 caliber machine gun had proven itself extraordinarily dependable in service, functioning reliably under the most adverse conditions. The Hispano cannon, while occasionally temperamental in British installations, worked well in the P-38's mounting. American pilots could expect their guns to fire when needed, a reliability advantage that German pilots flying MG-151 cannon and MG-131 machine guns could not always claim by late 1944, when manufacturing quality had deteriorated significantly. The fuel system demonstrated American attention to operational requirements. The Lightning's 10 internal fuel tanks, distributed throughout the center section and wing leading edges, fed both engines through a complex transfer system that maintained proper weight distribution throughout the flight. Pilots could manage fuel transfer manually or allow automatic systems to maintain balance, reducing workload during long missions. The capacity for external drop tanks extended range dramatically, and the drop mechanism was simple and reliable. German engineers recognized this as another area where American design philosophy differed fundamentally from German approaches. The P-38 was designed from the beginning as a long-range aircraft. Every system reflected that mission priority. Fuel capacity, engine efficiency, aerodynamic cleanliness, all optimized for reaching distant targets and returning safely. German fighters, designed primarily for short-range point defense of German airspace, sacrificed range for other characteristics. The result was fighters that could defend Germany for 90 minutes at most, while Allied escorts could remain over German targets for hours. The hydraulic and electrical systems also impressed German technical specialists. The P-38 had comprehensive electrical power generation with 2 engine-driven generators, providing redundant power for radios, instruments, and systems. The hydraulic system, powered by 2 engine-driven pumps, operated landing gear, flaps, brakes, and other accessories reliably. Everything was duplicated, providing fault tolerance that meant single failures did not compromise the aircraft's ability to complete its mission and return to base. This redundancy reflected American engineering priorities that differed from German practice. German aircraft designers, operating under severe weight and material constraints, minimized redundancy to save weight and reduce complexity. The approach worked adequately when aircraft were new and well maintained, but under combat conditions, where battle damage was common and maintenance was difficult, the lack of redundancy translated to higher loss rates from system failures. The construction techniques used in P-38 manufacturing revealed another uncomfortable truth. The Lightning was built using semi-monocoque stressed skin construction, with carefully formed aluminum alloy components joined by flush riveting. The attention to surface smoothness was exceptional, minimizing parasitic drag throughout the airframe. German engineers recognized that achieving such smooth surfaces at production rates that Lockheed claimed seemed nearly impossible with available German manufacturing capabilities by late 1944. Quality control throughout the captured Lightning was consistently high. Skin panels fit precisely. Riveting was uniform and properly formed. Internal systems were neatly routed and carefully secured. The aircraft showed none of the crude shortcuts and careless workmanship that increasingly characterized late-war German fighter production, as skilled workers were conscripted for military service and replaced by forced laborers, working under harsh conditions with inadequate training and motivation. By late November 1944, the technical evaluation had generated sufficient data for comprehensive analysis. The intelligence reports circulated through Luftwaffe fighter commands, providing operational units with accurate information about P-38 capabilities and limitations. The conclusions were sobering but valuable. German pilots needed to understand exactly what they faced when engaging P-38 seconds, both to maximize their limited advantages and to avoid tactical situations that played to Lightning's strengths. The recommended tactics emphasized exploiting the P-38's only significant weakness, its inferior sustained turn performance in slow-speed combat. German pilots were advised to force turning engagements whenever possible, using the Bf-109's superior turn radius to gain firing position. However, the reports acknowledged that competent P-38 pilots would refuse such engagements, using superior speed to disengage at will. Alternative tactics focused on attacking P-38 seconds when they were engaged with other German fighters and unable to freely maneuver, or catching them at disadvantage during takeoff or landing when speed and altitude advantages did not apply. Neither approach offered reliable success, merely incremental improvements in extremely unfavorable tactical situations. The evaluation program's next phase involved demonstration flights to operational units, following the proven model of the Wonder Zirkus Rosarius. The captured P-38, now bearing full Luftwaffe markings and coded T9+MK, would visit fighter bases across Germany, allowing frontline pilots to see the aircraft in flight and observe mock combat demonstrations that illustrated both German advantages and P-38 superiority. The first demonstration flight occurred at Jüterbog Damm Airfield southeast of Berlin on December 3, 1944. The 1st Fighter Division had assembled representatives from multiple squadrons. Approximately 80 pilots gathered in the cold morning air to witness something most had only encountered as distant silhouettes at high altitude or fleeting targets in chaotic combat. The briefing before the flight demonstration was conducted by Major Heinz Baer, a highly decorated ace with over 200 victories who had extensive experience evaluating captured aircraft. Baer understood that German pilots needed honest assessment, not propaganda. The men facing him would stake their lives on the information he provided. False optimism would kill them as surely as enemy bullets. "Gentlemen," Baer began, his breath visible in the December cold, "what you are about to observe will challenge assumptions you may hold about twin-engine fighters. The Americans have achieved something we attempted with the Bf-110 and abandoned after the losses over Britain. They have created a twin-engine fighter that performs competitively with single-engine types in most combat situations and decisively surpasses them in range and altitude performance." The assembled pilots shifted uncomfortably. Many had heard rumors about the P-38's capabilities, but official communications from higher headquarters often downplayed Allied aircraft performance to maintain morale. Hearing a respected combat veteran like Baer acknowledge American technical success carried weight that official bulletins lacked, Baer continued, outlining the Lightning's specifications as determined through testing at Rechlin. Maximum speed approximately 414 miles per hour at 25,000 feet, service ceiling over 40,000 feet, combat radius with external tanks exceeding 700 miles, more than triple the Bf-109G's effective range. Armament of 120mm cannon and 4 .50 caliber machine guns, all nose-mounted for exceptional accuracy. The P-38 cannot sustain turn with a Bf-109 or foe 190 inches slow-speed combat, Baer explained. This is your advantage. However, exploiting this advantage requires forcing the engagement, and the Lightning pilot can refuse combat at will, using superior speed and climb rate. If he chooses to disengage, you cannot stop him. If he chooses to fight using energy tactics, you cannot defeat him at altitudes above 20,000 feet, where our engines lose power and his turbo superchargers maintain full performance. The tactical briefing lasted 30 minutes, after which the pilots filed outside to observe the flight demonstration. Hauptmann Baumbach, who had conducted the initial evaluation flights, would fly the captured P-38 through a series of maneuvers designed to illustrate its capabilities. A Bf-109 G-14 and an FW-190A-8, representing the Luftwaffe's most current operational fighters, would fly alongside for direct comparison. The Lightning's startup and taxi drew immediate attention. The distinctive sound of two Allison engines, the unusual tricycle landing gear, the twin-boom configuration, everything about the aircraft seemed alien compared to the conventional single-engine fighters that dominated Luftwaffe service. When Baumbach advanced throttles for takeoff, the P-38's acceleration visibly exceeded the comparison fighters, despite taking off with additional weight in ballast to simulate combat loading. Once airborne, the formation climbed to 10,000 feet, where the demonstration would be conducted. Baumbach began with basic handling displays, rolling the Lightning through a series of aileron rolls that demonstrated crisp roll rate, then transitioning to loops that showed adequate pitch authority and energy retention. The P-38 looked nimble, contradicting the heavy, sluggish handling characteristics that German pilots associated with twin-engine aircraft. The speed comparison came next. All three aircraft accelerated from cruise speed to maximum velocity in level flight. The P-38 pulled steadily ahead of both German fighters, opening distance that grew progressively larger despite the Bf-109 and foe W-190 running at maximum continuous power. The visual demonstration was more convincing than any written report. German pilots on the ground watched the Lightning disappear into the distance, a shrinking speck that their fighters could not catch. Baumbach then demonstrated the climb rate advantage. All three aircraft pulled vertical from level flight at Lottind, 250 miles per hour. The P-38 maintained its climb angle longer than either German fighter, its superior power-to-weight ratio and efficient aerodynamics, keeping the nose pointed skyward while the comparison fighters fell away into shallower climbs. At 10,000 feet, both German types were struggling to maintain climb attitude. The Lightning continued upward, seemingly defying gravity. The mock combat demonstration provided the most valuable and sobering lessons. An experienced Luftwaffe pilot in the Bf-109G-14, Oberleutnant Franz Stigler with 28 victories, attempted to engage the P-38 using standard German fighter tactics. Stigler had volunteered for the demonstration, confident that his experience and the 109's superior turn performance would allow him to achieve firing position despite the Lightning's speed advantage. The engagement began with both aircraft at 15,000 feet, separated by approximately 2 miles, approaching head-on. This simulated the typical encounter geometry when German fighters intercepted bomber formations and their escorts. As the aircraft closed, Stigler turned hard into Baumbach's P-38, attempting to use his superior turn radius to cut inside the Lightning's turn circle and gain a firing position on the American fighter's tail. Baumbach recognized the tactic immediately and responded exactly as a competent P-38 pilot would in actual combat. Rather than accepting the turning fight where the 109 held advantage, he rolled wings level, pushed the throttles forward to military power, and accelerated away from the engagement. Stigler attempted to follow, his Bf-109 at full power, but the speed differential was decisive. The P-38 opened distance at approximately 50 miles per hour closure rate, pulling out of gun range within seconds. Stigler tried again, this time attempting to intercept from above, using altitude advantage to build speed in a diving attack. He rolled inverted and pulled through into a 60-degree dive, accelerating to nearly 400 miles per hour indicated before beginning his firing pass on the P-38 below. Baumbach saw the attack developing and reacted appropriately, rolling into his own steep dive and accelerating away from the pursuing 109. At 420 miles per hour, Stigler's Bf-109 was approaching its handling limits. Control forces had increased dramatically, requiring both hands on the stick to make even small corrections. The aircraft was wallowing, buffeting, and showing clear signs of approaching compressibility. Baumbach's P-38, at the same speed, remained stable and responsive. When Baumbach pulled smoothly out of the dive and transitioned to a zoom climb, Stigler could not follow without risking structural failure or loss of control. The pilots on the ground watched this sequence with growing comprehension. Their most experienced combat pilot, in their best operational fighter, could not successfully engage the American aircraft despite multiple attempts using varied tactical approaches. If Stigler could not achieve firing position against the P-38, what chance did less experienced pilots have in actual combat where the stakes were life and death? The final demonstration involved high-altitude performance. Both aircraft climbed to 25,000 feet where American bomber formations typically operated. At this altitude, Stigler's Bf-109G-14, equipped with a DB-605AM engine and MW-50 methanol water injection for boost, represented the best high-altitude performance available in operational German fighters. The speed comparison at altitude was devastating. The P-38's turbo-supercharged engines maintained sea-level power, delivering full performance despite the thin air at 25,000 feet. Baumbach's Lightning accelerated smoothly to maximum speed, pulling away from Stigler's laboring Bf-109 as though the German fighter were standing still. The 109's DB-605 engine, gasping in the thin atmosphere, could not generate sufficient power to close the gap. The admission from such an experienced and respected pilot carried enormous weight. If Stigler, with his skill and experience, could not defeat the P-38's controlled mock combat, the average German fighter pilot with minimal training and limited experience faced impossible odds in actual engagements. The questions that followed the demonstration reflected the pilots' concern and confusion. Many wanted to know why German engineers had not developed similar capabilities in Luftwaffe fighters. The answer was complex, involving resource constraints, strategic priorities, and fundamental differences in design philosophy, but the underlying reality was uncomfortable. By late 1944, German engineering was no longer competitive with Allied achievements in several critical areas. Oberleutnant Hans Wake, a 20-victory ace from JG5 operating on the Northern Front, asked about the P-38's reported vulnerability to engine fires and its tendency to lose control in high-speed dives, characteristics mentioned in intelligence reports compiled from earlier combat encounters. Baumbach acknowledged that early P-38 variants had experienced these problems, but explained that American engineers had systematically addressed the issues through improved intercoolers, modified dive recovery flaps, and revised operational procedures. The aircraft you observe today represents the P-38J model, incorporating all these improvements, Baumbach explained. The engine cooling problems that plagued earlier variants in the European theatre have been largely eliminated. The compressibility issues that caused loss of control in steep dives have been mitigated through aerodynamic modifications. The Americans identified problems, analyzed root causes, and implemented effective solutions. This is not the same aircraft that began combat operations in 1942. It has evolved through continuous refinement based on operational experience. This revelation highlighted another uncomfortable reality. American forces possessed the industrial capacity, technical expertise, and systematic approach to identify problems in combat equipment and rapidly implement improvements across their entire inventory. German forces, by contrast, were increasingly unable to incorporate even critical modifications into production aircraft due to dispersed manufacturing, material shortages, and the general chaos of a collapsing industrial infrastructure under relentless Allied bombing. Your best opportunity is during the initial engagement when the P-38 seconds are tied to the bombers and cannot freely maneuver, Clade explained. Make your attack as fast as possible from an advantageous position, achieve firing solution quickly, and disengage immediately before the escorts can respond. Do not remain engaged with P-38 seconds. Do not attempt to turn with them unless you have significant energy advantage and can complete your attack before they accelerate away. Your goal is to reach the bombers, not to fight the escorts. The guidance reflected the desperate tactical situation German fighters faced by late 1944. The Luftwaffe's mission was to destroy American bombers and prevent the systematic destruction of German industry and cities. But achieving this mission required first penetrating screens of superior Allied fighters that possessed decisive performance advantages. German pilots were essentially ordered to fight through opponents they could not defeat, to reach targets they could barely damage due to the bombers' heavy defensive armament and robust construction. The psychological impact of these demonstrations was profound and varied among individual pilots. Experienced veterans who had survived years of combat recognized the information's value despite its sobering implications. They understood that accurate intelligence about enemy capabilities improved survival chances by enabling realistic tactical planning. Better to know the truth and adapt tactics accordingly than to base decisions on comfortable illusions that would prove fatal in actual combat. Younger, less experienced pilots often reacted with visible despair. Many had entered fighter training believing they would fly advanced aircraft superior to enemy types, confident that German engineering excellence and tactical prowess would overcome Allied numerical superiority. The demonstrations shattered these beliefs, revealing that German fighters were outperformed in most critical categories by Allied types, particularly at the high altitudes where bomber escort combat occurred. Some pilots expressed anger at what they perceived as betrayal by higher headquarters that had misled them about the true tactical situation. Others questioned why they were being sent into combat in inferior aircraft against overwhelming odds. The demonstrations, while valuable for tactical education, inevitably damaged morale by forcing acknowledgement of Germany's deteriorating military position. The broader context of these demonstrations was Germany's complete strategic collapse during the winter of 1944 through 1945. On the Eastern Front, Soviet forces were advancing relentlessly, having liberated most of occupied Soviet territory and pushing into Poland and the Balkans. In the West, Allied forces had recovered from the initial shock of the Ardennes offensive and were preparing to cross the Rhine into Germany itself. The strategic bombing campaign was systematically destroying German industrial capacity, oil production, and transportation infrastructure. Within this context of comprehensive military defeat, the captured P-38 demonstrations represented one small element of Germany's desperate attempt to extract every possible advantage from increasingly hopeless circumstances. The Luftwaffe could not change the reality that Allied fighters possessed superior performance. It could not increase fuel allocations to extend training for new pilots. It could not accelerate production to replace losses that exceeded sustainable rates. But it could provide accurate tactical intelligence to operational units, potentially improving survival rates marginally and enabling more effective execution of assigned missions, even if ultimate success was unachievable. The fate of the specific P-38 that conducted these demonstrations remains uncertain. Historical records suggest the aircraft continued flying with the Wanda Circus Rosarius through January 1945, but its ultimate disposition is unclear. Several possibilities exist, each reflecting the chaos of Germany's final months. The aircraft may have been destroyed on the ground during an Allied air raid against one of the airfields it visited, German airfields were under constant attack during early 1945, with Allied fighters strafing any aircraft visible on the ground. Alternatively, the Lightning may have been deliberately destroyed by retreating German forces to prevent its recapture, as Allied armies advanced into Germany from both east and west. German forces systematically destroyed equipment, documentation, and facilities as they retreated, following scorched earth policies intended to deny resources to advancing enemies. A captured P-38 bearing German markings would have been high-value intelligence if recaptured by Allied forces, potentially revealing the extent of German knowledge about American aircraft capabilities and the effectiveness of the Wunderzirkus Rosarius program. The jet aircraft highlighted another uncomfortable comparison. Germany had successfully developed revolutionary jet propulsion technology before the Allies, achieving operational deployment of jet fighters, while American and British jet programs remained in testing stages. Yet this technological advantage provided no strategic benefit. The Me-262 was faster than any Allied piston engine fighter, but chronic engine reliability problems, severe fuel shortages, inadequate pilot training, and overwhelming Allied numerical superiority prevented the type from significantly impacting the air war's outcome. The P-38, by contrast, represented mature, reliable technology successfully implemented at massive scale. Lockheed produced approximately 10,000 Lightnings between 1941 and 1945, with production peaking at approximately 400 aircraft monthly during 1944. This output demonstrated American industrial capabilities that German production could not approach. Even if German engineers had perfectly understood P-38 design principles and possessed complete technical documentation, German industry lacked the capacity to replicate such production under wartime conditions of resource scarcity and infrastructure destruction. The comparison extended beyond mere production numbers to questions of quality and reliability. The captured P-38 seconds evaluated at Rechlin were consistently well manufactured, with high-quality materials, precise assembly, and reliable systems throughout. German aircraft production by late 1944 showed increasing quality problems, as skilled workers were conscripted for military service and replaced by forced laborers working under harsh conditions with minimal training and motivation. The engine quality particularly diverged between American and German production. Allison V-1710 engines, installed in P-38 seconds, were manufactured to tight tolerances, using high-quality alloys, with thorough quality control ensuring consistent reliability. German Daimler-Benz DB605 and Junkers Jumo 213 engines, while sophisticated designs, suffered increasing quality problems during 1944 and 1945 as material shortages, forced substitution of inferior alloys and production dispersal to avoid bombing reduced quality control. Effectiveness. The result was German engines with unpredictable reliability, shorter time between overhauls, and higher failure rates compared to earlier production. Pilots never knew whether their engine would complete the mission or fail catastrophically at a critical moment. This unreliability, combined with chronic fuel shortages that prevented adequate pre-flight testing and engine warm-up, contributed significantly to German operational losses from non-combat causes. The captured P-38 evaluations also revealed American sophistication in human factors engineering and pilot accommodation. The Lightning's cockpit layout reflected careful attention to reducing pilot workload and fatigue during long missions. Controls were logically positioned, instruments were clearly marked and sensibly grouped, and the overall ergonomics facilitated effective operation under stress. German fighter cockpits, by contrast, often reflected engineering priorities that emphasized technical performance over pilot accommodation. The Bf-109's cramped cockpit, with its heavily framed canopy, restricted visibility and limited freedom of movement. The control layout was functional but not optimal, with some switches and controls positioned where they were difficult to reach during combat maneuvering. These design characteristics might seem minor, but their cumulative effect during multi-hour missions was significant pilot fatigue that degraded performance and decision-making. The strategic implications of P-38 capabilities extended well beyond individual aircraft performance. The Lightning's range fundamentally transformed bomber escort operations in ways that proved decisive to the strategic bombing campaign's success. Before long-range escorts became available in sufficient numbers, American bomber formations suffered unsustainable losses during deep penetration raids into Germany. The most dramatic example was the second Schweinfurt raid on October 14, 1943, when 8th Air Force lost 60 B-17 bombers from a force of 291 aircraft, a loss rate exceeding 20%. Such losses could not be sustained. Deep penetration missions were temporarily suspended, while the 8th Air Force waited for fighters with sufficient range to escort bombers throughout entire missions. The P-38, along with the P-51 Mustang and to a lesser extent the P-47 Thunderbolt equipped with external tanks, provided this essential long-range escort capability beginning in early 1944. By the time German test pilots were systematically evaluating captured P-38 seconds in the autumn of 1944, the strategic air war had already shifted decisively in the Allies' favor. German fighters could no longer find extended periods when bombers flew unescorted and vulnerable. Every mission now included fighter coverage throughout, forcing German interceptors to fight through superior Allied fighters to reach bomber formations. The loss rates reflected this changed tactical situation. German fighter losses increased dramatically during 1944, reaching levels that could not possibly be sustained given the constraints on pilot training and aircraft production. Experienced pilots who understood through years of combat how to maximize their aircraft's limited strengths while minimizing exposure to enemy advantages were being killed at rates exceeding the ability to train replacements. New pilots arrived at operational units with barely 100 hours total flight time, minimal combat training, and often no instrument flying instruction. These inadequately prepared pilots faced veteran American pilots flying objectively superior aircraft like the P-38 and P-51. The outcome was grimly predictable. Average survival time for new German fighter pilots during late 1944 and early 1945 was measured in single-digit mission counts. Most were shot down, killed, or seriously wounded within their first 5 combat sorties. The Wanda Circus Rosarius demonstrations attempted to improve these grim statistics by providing new pilots with realistic understanding of enemy aircraft capabilities before they encountered them in combat, where ignorance proved fatal. The program achieved modest success. Pilots who attended demonstrations and absorbed the tactical lessons showed marginally better survival rates than those who entered combat completely unprepared. But no amount of tactical knowledge could overcome the fundamental disparities in aircraft performance, pilot training quality, and numerical strength that characterized the air war by late 1944. The final assessment of the P-38 Lightning from German test pilots and tactical evaluators was professionally respectful, despite their enemy status. German aviation professionals recognized sophisticated engineering when they encountered it directly. The Lightning represented successful integration of complex systems into an effective weapon that achieved its design objectives admirably. The twin-engine configuration, rather than being a fatal compromise as German assumptions suggested, provided capabilities that single-engine fighters could not match within the technology constraints of the era. The turbo-supercharger installation enabled performance at altitudes where naturally aspirated engines struggled. The concentrated nose armament provided exceptional accuracy and devastating firepower. The long range allowed escort missions deep into Germany and sustained combat air patrol over target areas. The robust construction enabled survival of battle damage that would have destroyed lighter aircraft. The reliable systems and thoughtful human factors engineering reduced pilot workload and fatigue during extended missions. Most importantly, the P-38 could be produced in large numbers with consistent quality, fielded to operational units with adequate spare parts and support equipment, and flown by thoroughly trained pilots who understood how to exploit its strengths. This combination of technical capability and logistical support made the Lightning a strategically decisive weapon system, despite its limitations in sustained turning combat. The admission by German test pilots that they had never built twin-engine Speed represented acknowledgement of American engineering achievement in successfully optimizing a complex aircraft design for specific mission requirements. The Germans had attempted twin-engine fighters with the Bf 110 and Me 410, but both types proved vulnerable in daylight combat against more maneuverable single-engine opponents. The conventional wisdom within the Luftwaffe held that twin engines necessarily meant inadequate combat performance for air superiority missions. The P-38 proved this assumption wrong through careful aerodynamic design, powerful engines effectively utilized through turbo supercharging, and systems integration that maximized strengths while minimizing weaknesses. American designers had achieved what German engineers had attempted and abandoned, creating a twin-engine fighter that could fight competitively in demanding daylight combat while providing the range and altitude performance that strategic missions required. This achievement reflected broader American capabilities in engineering education, industrial organization, and systematic problem-solving. The United States possessed extensive engineering talent, supported by universities producing thousands of graduate engineers annually. American industry had developed sophisticated production engineering and quality control methods that enabled consistent manufacture of complex equipment at massive scale. The systematic approach to identifying problems in combat equipment and rapidly implementing solutions demonstrated organizational competence that Germany increasingly lacked by late 1944. The story of German pilots testing captured P-38 seconds, and confronting their own inadequate twin-engine fighter development parallels the broader narrative of Germany's military defeat in World War II. Initial German advantages in tactical doctrine, combat experience, and some areas of technology gradually eroded as the war progressed, and Allied nations mobilized their superior resources, larger populations, and greater industrial capacity. By late 1944, the cumulative advantages of Allied material superiority had become overwhelming. No amount of tactical skill, individual courage, or even technological innovation in limited areas could overcome the fundamental disparities in resources, production capacity, and trained personnel. German forces fought with remarkable effectiveness given their circumstances, but faced opponents who possessed decisive advantages in almost every dimension of military power. The captured aircraft testing program represented Germany's systematic attempt to extract maximum tactical value from limited resources through superior intelligence and training. The program succeeded in providing valuable information to German pilots, potentially improving their survival rates marginally. But it could not change strategic realities. German fighters remained inferior in critical performance categories. German pilots remained inadequately trained due to fuel shortages. German aircraft production could not replace losses, and Germany's overall strategic position continued deteriorating toward inevitable total defeat. The final months of the war saw the Wanda Zirkus Rosarius gradually cease operations as fuel became unavailable for demonstration flights, as operational priorities absorbed all remaining aviation resources, and as advancing Allied armies overran the airfields where demonstrations had been conducted. The program quietly ended, not through formal disbandment but through the general collapse of German military organization during the war's final chaotic weeks. The Lightning's success challenged comfortable assumptions within the Luftwaffe about inherent Teutonic technical superiority, forcing acknowledgement through direct experience that adversaries possessed formidable capabilities, requiring professional respect rather than dismissal through propaganda. The aircraft proved that twin-engine fighters could achieve combat effectiveness in demanding roles if designed correctly and employed properly, contradicting German doctrinal assumptions based on earlier failures. Most fundamentally, the captured P-38 testing revealed that material advantages ultimately proved decisive in industrial warfare when disparities reach sufficient magnitude. Tactical skill, courage, and innovation can achieve impressive results against superior opponents in specific engagements, but cannot overcome systematic disadvantages in aircraft performance, production capacity, pilot training quality, fuel availability, and numerical strength sustained across thousands of combat sorties over years of continuous operations. The German test pilots who flew captured Lightnings understood these realities through direct experience that could not be dismissed or rationalized away. They provided valuable tactical intelligence to operational units, fulfilling their professional responsibilities with competence despite hopeless strategic circumstances. Their admission that Germany had never built twin-engine speed represented honest professional assessment of American engineering achievement, recognition that adversaries had successfully solved technical problems that had defeated German attempts, and implicit acknowledgement that the war was lost and had been for some time, regardless of continued resistance or propaganda claims of secret weapons that would reverse Allied advantages. The P-38 Lightning continued serving American forces through war's end and beyond, the distinctive twin-boom fighter remaining operational in some roles into the early 1950s. The aircraft that German test pilots evaluated with professional interest and grudging respect represented one element of Allied material superiority that proved decisive in achieving victory in history's most destructive war. The technical sophistication, production scale, and operational effectiveness combined in the Lightning demonstrated capabilities that Germany could neither match nor effectively counter, given the strategic and material constraints of late 1944. The captured aircraft sat on that Rechlin hardstand in October 1944 as tangible evidence of these uncomfortable realities, its yellow identification markings and Luftwaffe codes unable to transform an American fighter into a German weapon or alter the fundamental imbalances that would determine the war's outcome. German pilots flew it, studied it, and learned from it, extracting whatever tactical value could be gained from understanding enemy capabilities. Then they returned to operational units and flew their inferior aircraft against overwhelming odds because duty demanded it, and strategic collapse left no alternative, carrying knowledge gained from captured Lightning that improved their tactics marginally while changing nothing about the war's inevitable conclusion. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.